Hello everyone and good day. Today we are going to talk about problem solving involving quantitative relationships in chemical reaction. And first we are going to talk about the formula and molecular weights. First is formula weight. Formula weight is the sum of atomic weights for the atoms shown in the chemical formula. Next is molecular weight. Molecular weight is the sum of the atomic weights of the atoms in a molecule as shown in the molecular formula unit. So, if a substance exists as discrete molecules as with atoms that are chemically bonded together, then the chemical formula is the molecular weight. And the formula weight is also the molecular weight. For example is the exercise number 1, where we are asked to calculate the formula or molecular weight of the following. And I chose letter A, which is glucose. In glucose, we have carbon, hydrogen, and oxygen, which can chemically bond to form molecule of glucose with the chemical and molecular formula of C6, H12, and O6. So, the formula weight and the molecular weight of glucose is thus: we have 6 carbon atoms, 12 hydrogen atoms, and we have 6 oxygen atoms. So to get the formula weight or molecular weight of glucose, we have to multiply the numbers of element to the atomic mass unit of that element. So first is the carbon. The atomic mass unit of carbon is 12.01, 1.008 for hydrogen, and 16 atomic mass units for oxygen. So we just have to multiply 12 or the atomic mass units to the atomic number or the numbers of atom. So after we multiplied, we're going to add them, and that gives us 180.156 atomic mass unit. Next, we're going to talk about percentage composition from formulas. In some types of analysis, it is important to know the percentage by mass of each type of element in a compound. The law of definite proportion states that a chemical compound always contains the same proportion of elements by mass, and that is percent composition, which is a list of the mass percent of each element in a compound. The mass percent is calculated by the formula: percent of element X is equal to number of atoms of element X times atomic weight of element X divided by formula weight of compound multiplied by 100. And that's the formula to get the percentage of the element in a compound. So, for example, is the exercise number 5, where we are asked what is the percent carbon in glucose. But before we find the percent carbon in glucose, we need to find the formula weight of the glucose, where we already did in the exercise number 1. And we got 180.156 atomic mass unit. Now that we have the formula weight, we can solve for the percent carbon in glucose by using the formula. And here is the answer. The percent carbon is equals to 6 6, which is the number of atoms of element carbon, and 12.0 times 12.01, which is the atomic weight of the element carbon, and divided by the formula weight of the compound, or the formula weight of glucose, and that is multiplied by 100, which gives us 39.99%. We are done with formula and molecular weights and percentage composition from formulas. Now let us go to balancing chemical equations. A balanced equation has the same number of each kind of atom on each side of the equation. And that is called the law of conservation of matter. For example, is the exercise number 6, where we are asked to balance the following chemical equations and determine the type of reaction. So first, we're going to balance the chemical equations. And we have here the reactant H2 plus I2. And in product side we have hydrogen, or H and I. So here we have, in the reactant side, we have 2 hydrogen and 2 iodine. And on the product side, we only have 1 hydrogen and 1 iodine. So what are we going to do to balance the equation? So since we have 2 hydrogen here and 2 iodine here, we have to make this hydrogen and iodine equal to the reactant side, or this product side to the reactant side. And for us to be able to do that, we can add coefficient, because the subscript here cannot be changed. So we are not allowed to change the subscripts 2 on the hydrogen and 2 on the iodine. So the thing that we can do is to add coefficient number. And here we can just add 2 coefficient. And these 2, since we put a coefficient here, that gives us 1 times 2 equals to 2, and 1 times 2 equals to 2. And that makes our hydrogen and iodine equals to 2. And now the reactant side and the product side are balanced. So the type of reaction here is combination. Why? Because 2 elements combine to form 1 product. And that's why the type of reaction is combination.